Day 2 of section 6 in chapter 8 is still choosing a factoring method. So by the end of this lesson, we want to be able to choose the appropriate method for factoring a polynomial. Remember, we talked about difference of squares, we talked about a perfect square trinomial, we also talked about checking for a greatest common factor before you factor. And if you wrote this down in the previous lesson, you don't have to write it down again, but please make sure you do have it written down somewhere. Remember, we're looking for a greatest common factor. Then we're trying to see if we can break down what's left over into two binomials. If there's no greatest common factor, then we're just going to break it down into the two binomials. If there's no middle term, we have probably a difference of squares, where the two parentheses are identical, but the signs are opposite. And we can also be checking for a perfect square trinomial. So factor completely. We have 3x cubed plus 6x squared plus 6x. This looks very different. Notice every term has an x in it, and every term is divisible by 3. So we can actually factor out a 3x. That leaves us with x squared plus 2x plus 2. And then typically we would check to see if this factors. So if it factors, that means that there are factors of 2, the back term, and the only factors of 2 are 1 and 2, that would add up to 2. But if you notice, 1 plus 2 is 3. So this, what's left over, does not factor. So this is your answer, 3x times x squared plus 2x plus 2. Again, factor completely, so we're looking for a GCF probably. We have 5x to the 4th minus 20x cubed. So if we factor out a 5 and an x cubed, we're left with x minus 4. This also does not factor. This is not a difference of squares. Even though 4 is a perfect square, x is not a perfect square. We would have to have x squared here. So this is your final answer. Try this one on your own, look for the GCF, and try to factor that out properly. The last term doesn't have a coefficient, so I can't factor out a 2 because the first two terms are divisible by 2, but the last term doesn't have a 2. But I can factor out an x and a y. That's going to leave me with 2x squared y plus 4x plus 1. Remember, you have to have that placeholder whenever you factor out a complete term, so that when we distribute back through, you are taking xy times 1 to give you that xy, that last term. I may skip some examples today. There are quite a few on here, but I probably will skip some. So number 4, we have x squared plus 7x plus 12. Because there's no coefficient, there's nothing I can factor out. We're looking for factors of 12 that add up to 7. And hopefully you see that it's 3 and 4. So we have x's in the front, so we don't have to worry about a coefficient because there isn't one. And our signs are both addition. The back number is positive, so the signs are the same and they match the middle. And it's x plus 3 and x plus 4. Remember, you can have those reversed, x plus 4 times x plus 3. We're going to go ahead and skip 5, and we're going to go to 6. 6, we have 4x squared minus 20x plus 25. And if you're not thinking about a perfect square trinomial, you might overlook this, but this is in fact a perfect square trinomial. Remember, the front can be factored into 2x times 2x. The back is 5 times 5. The middle then would be 2 times the 2x times the 5, and that does give you 20x. So in the fronts we have 2x, in the backs we have 5s, and our signs are identical because remember, in a perfect square trinomial you can write it as a quantity squared. So we get 2x minus 5 quantity squared. If you didn't see that it was a perfect square trinomial, you can still factor it, and just do the guess and check method that we've done in the past, you will eventually get to the right answer. 7's also a perfect square trinomial. It looks a little different because we have that extra variable in the back, but in the front, remember it's 2a times 2a. In the back, it's 9b times 9b. And in the middle, we have 2 times 2a times 9b. That's a negative, or that's 36ab. So in the front, we have 2a's. In the backs, we have 9b's. And our signs are both subtraction. And again, if you want to write it as a quantity squared, you can do that. 8 is the first example where it's a difference of squares, and hopefully you see that because we don't have a middle term. There's no z term in the middle. It's just z squared and 25. So when we factor a difference of squares, it's z plus 5 and z minus 5. Remember, they're identical except for the sign is different. And some of you were forgetting that, so try to remember difference of squares, the signs are different. We'll skip 9 and try 10. 81n squared minus 121. Again, they're both perfect squares, 81n squared and 121. So it's 9n plus 11 and 9n minus 11. It can't be written as a quantity squared because they're not identical. The signs are different. It looks a little similar to one we did earlier, but watch what happens when we factor out the GCF here. If I take out a 5x, because they both have 5x in common, I'm left with x squared minus 4. What I'm left with is a difference of squares, so this needs to be factored more. So I bring down the 5x, and I factor the x squared minus 4 into x plus 2 times x minus 2. So sometimes when you take out that GCF, what you're left with, you can still factor. So you have to pay attention to that. Example 12 is similar if you want. I'm not going to finish it, but if you factor out a 3, you get u squared minus 9. Notice this is a difference of squares, which then can be factored. And I guess I will. It factors into u plus 3 and u minus 3. And I think the last one we'll do is 13. Here's a big one where we need to factor something out. They all have a 2 in common and an x. So if I factor out a 2x, I'm left with x squared minus 16x plus 64. And what you're left with is actually a perfect square trinomial. But if you don't see that, that's okay. You can factor using the guess and check method. I have x's up front. Both signs are subtraction. 64 is a perfect square. It is 8 times 8. And if you want, you could rewrite this as 2x times x minus 8 quantity squared. Either answer is acceptable, the second or the third line. 14, if you want to try to factor that one on your own, you can. So I'll leave the video here for a moment so you can write it down. Remember, you need to factor out the greatest common factor first before you try to factor. And 15 is the same case. It does say factor completely. A lot of times that's a good tip, that there is a greatest common factor. But we need to factor something out first before you try to factor the trinomial. Hopefully you feel a little more comfortable with all the different types of polynomials we've talked about so that you can factor and choose the best method or the fastest method. And when we are in class next, we'll work on worksheet 8.6b.